Student? 2. Okay, now we're doing, okay, we're getting a few. We got a few. Okay. Carolyn, first of all, what kind of an output are we looking for?
An angle.
Okay, so we want an angle. Now these guys are inverses of each other. So is this in the domain of this one? Yes, so we can evaluate it. Okay, is this, since they're inverses, is it in the range of this one? No. So we have to ask ourselves, the cosine of what is the cosine of 5 pi over 4? What is it?
Negative square root of 2 over 2.
Okay, so the cos inverse is negative, the cosine of 5 pi over 4 is negative square root of 2 over 2. Let me just think about this. 5 pi over 4, yes, because it's in the third quadrant, okay? But we need a 1 or 2 quadrant angle. Okay, so what would it be?
3 pi over 4.
Is that what you guys, who got that?
Why can't it just be pi over 4?
Because this is a negative. So let's go back to our unit circle. So in our unit circle, so 5 pi over 4 was right here. Shh. This is 5 pi over 4. So definitely we can take the cosine of 5 pi over 4. And in the unit circle, that's going to, it's negative square root of 2 over 2. Okay, so now the range of cos inverse is from 0 to pi. So it has to be from here to here, but from 0 to pi over 2, it's, the cosine is positive, so it has to be that one, okay?
Oh, because it has to be in the range.
Yep, yep, has to be in the range of that cos inverse, okay?
So it's not in the domain of cos.
What's,
Oh, I'm just working on the next one. Sorry.
oh, you're working on
I'm
this
just
one.
trying to think. So it has to be in the domain, like in order for you to be able to, like.
I don't know. I just don't get how you got 3 pi over 4.
Okay, so let's talk about cos inverse. Y equals cos inverse of x. What is the range of this one? What's the,
0 to pi.
so the 5 pi over 4 is in the domain of cosine, because the cosine, the domain of the regular cosine function is all reals. Okay, so we're good with that, right? Okay. But 5 pi over 4 is outside of this range. Okay, so when I look at the unit circle, that's why I brought up the unit circle. 5 pi over 4, here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So 5 pi over 4 is way over here. So when you, so the output, so the output for the cos of 5 pi over 4 is negative square root of 2 over 2. So the output for this inside part is negative square root of 2 over 2. So now I'm looking for the cosine, you could think of this, the cosine of what angle is negative square root of 2 over 2, where that angle has to come from this range.
Oh, okay.
You do?
Yeah,
Okay, because since it's from 0 to pi, here's pi. Well, in this quadrant, pi over 4 would give us the square root of 2 over 2 as an output, but it wouldn't give us a negative square root of 2 over 2. Okay, you good there now?
Yeah, I got it.
Okay, good questions. Anything else before we move to the next one? Okay. So, who thinks they got this one? Who hasn't even thought about it yet because you were still thinking about the last one? Okay, so let me give you a little bit of time to think about that. Who has this one? Okay, Johanna, what is it? No solution. Who agrees with her? Okay, Johanna, now I need you to explain why.
Because 2 isn't in the domain of the inverse.
2 is not in the domain of this. So once you see that it's not in the domain of this one, you're done. So let's just take a look at why. The domain of the cos inverse is from -1 to 1. This 2 right here falls outside of the domain of that inside function, so it cannot be evaluated, so no solution. Okay. Have you guys had time to do the next one? Who needs time to do number 11? Okay, take a little time. Take a little time. Wait, first of all, I want to see who has an answer for this. Who has an answer for this? Okay. All right. Okay, now, Cassidy, what did you get for the answer? I'm going to put it here, and then we're going to check on you.
I got 4/3.
4/3. Is that what you had, Tristan? Really? Okay. Well, I wasn't sure because you go, yes. It wasn't like a yes. It was like a yes. Do you see the difference? Okay. All right. So let's see. This is a good strategy for these type. The answer to the inside should be, to this part is an angle. So let's name the angle theta. Okay, so the let me start over. The cos inverse of 3/5. Cosine is adjacent over hypotenuse. So this is 3, this is 5, and then we can use the Pythagorean theorem to find this length, or
3, 4, 5.
we know that it's a 3, 4, 5 triangle, so that's a 4. Hey, how can I help you?
Can I get a compass?
You can look in that top drawer and see if you can find a workable one. Okay, so now we can take the tangent of that angle. So the tangent is opposite over adjacent, and Cassidy got it. Okay, are you guys groovy? Okay. Okay, now somebody pulled out her calculator on this one. You can do this one without a calculator.
Not on that one.
Oh, I'm 13. Excuse me. I'm sorry. Okay. So how do we come up? I'm a seeker. Okay. So how can we do this one? First of all, is this on the input of this?
Yes.
Is this in the output of this?
Yes.
So, bye-bye.
What's the answer, everyone? Okay. Is there anybody that didn't get that one?
It's 42.
Jump Jackson. Go, bud. All right. So if you can do that one, you can do this one. This is the composition of functions. And so earlier when I just asked you this, there wasn't a triangle that we could refer to. We tried, but we couldn't really. But we can do this because it's asking for something different. So we can do this on a non-calculated portion of a test. Okay, so if you haven't tried this one, do try it. Let's have theta be the output of the inside. Mm-hmm.
What's wrong?
Sam Lewis, what did you get? 1 over the square root of 5. Did anybody else get that?
Yes.
We have a few yeses. Okay, so here we go. So we are looking for a ratio because the outside function is a cosine. So we're taking the cosine of some angle. The input, is it in the domain of tan inverse? Yes?
Yes.
Okay. Because what is the domain of tan inverse? All real numbers. Okay, so the tangent is opposite over adjacent. Using the Pythagorean theorem, we get that this is the square root of 5. 1 squared plus 2 squared equals the hypotenuse squared. So that's 5, square root of 5 for this. And now we're taking the cosine of that angle. The cosine of that angle is adjacent over the hypotenuse. Let me put cosine of theta here. 1 over the square root of 5, or if you want to rationalize it, it's the square root of 5 over 5. Okay, real quick, I just got to do a quick check-in. Fist of 5 with working on these composition of the trig functions and their inverses. 4.5, I like that. Okay, so we still have some 3s with us. But when you first came in, show me where you were when you first came in. Okay, so we had some 0s with us, and those 0s are. Were you guys gone Friday? You were gone Friday. You were gone Friday. So that's pretty good to get to a 3 by the end of today. I think you guys just need a little more time with it. Okay, so I think I'm going to go ahead. Right now, this is what I'm going to tell you guys. I assigned on Friday, I assigned Skill Practice 13, just the Paul part, page 62. Now, I'm assigning all of Skill Practice 13. That's your assignment tonight. And so you can work on it now. There's about 10 minutes left in class, so you can work on it now. And then tomorrow, I'm going to assign Skill Practice 14. All right, and but tomorrow, before we assign Skill Practice 14, we'll go over any questions that you guys have from the Paul worksheet and page 383 to 385. Does that sound groovy? Zidane?
Could we get our quizzes back?
Let's see. I have a few culprits that haven't taken it yet,
Okay.
so I'd prefer having them take it first.
Okay.
So Dallas, and who else needs to take it? Tristan?
I know, I think it.
Tristan took it Friday or Monday. I kind of have to wait and see how we get through today and tomorrow.
Yeah, if it was.
It would be awesome, but then it wouldn't give us very much time to do the next unit.
Hey, we're almost done though.
Yeah, but
Kind of.
we still have 2 units.